This is Brandon Jones with Pact Publishing. In this section, we're going to discuss how to connect layouts and widgets to Kotlin functions. We're going to look at several videos, including this video on declaring variables, the next video on functions, an example of calling a Kotlin function in an activity from a button, an example of calling a Kotlin function from another Kotlin function, and in addition, we'll do a bit of refactoring. First, declaring variables. Variables are the places where we store items in memory while the computer is running. So in this video, we're going to look at variable types, specifically implied types of variables. We're going to consider var versus val, and then we're going to consider what happens when a variable does not contain a value at all, which is something we call null. First of all, implied types. In Java and most object-oriented languages, we have a word called polymorphism, which sounds more confusing than it really is. What it means is that we can declare a variable or a place in memory, and we can store an object in that place in memory. The variable will tell us what methods we are allowed to call, and the object will tell us what will happen when we call those methods. The problem happens when the object has more methods than the variable, because to call those methods, we have to do something called casting. And casting confuses a lot of people, especially who are new to programming. And if you don't cast properly, you end up with something called a class cast exception. Now in JavaScript is not considered strongly typed. So we don't strongly type variables, we simply use an all-purpose variable type, and the type of variable is inferred from the data inside. Kotlin is more like JavaScript than Java, but it does have a lot of the advantages of Java as well, where we can do things like call methods on our variables. So in Kotlin, the type is inferred from the object type. Let's look at an example in source from our previous video. You see here I'm declaring a variable called I, and inside of it I'm putting 1 plus 1. That means this variable I is type integer, because it's holding integer data. Now, there are two ways to declare a variable. One is a var, which is a variable where we can change the contents of that place in memory over time. That's the most common variable type we're going to use. The other is val. Val means the variable cannot change. An example of this is a constant. So if I were to say var I equals 60,000, that doesn't make a lot of sense in context. But what if I said this? Val 1 minute equals 60,000, because there are 60,000 milliseconds in a minute. Then later on in code, I can use that reference 1 minute. Okay, and we know that it's always going to contain 60,000 because we've set it up as a constant or something that can't change. But you see, this is very readable here. I could even say var 15 seconds equals 1 minute divided by 4. Just a moment, as I mistakenly hit insert. There we go. And you see, that's a much more readable phrase than var foo equals 60,000 divided by 4. So constants can make our source code much more readable, which means less we need to add comments to make the code readable. So var versus val. Var more common, val is something that would be a constant. Now, null types, this is another thing in traditional programming like Java that can get very confusing. Let's say that I have something that looks like this. I have var foo equals null, okay? And then I say foo.length. In Java, what I'm doing is I'm trying to call, this is not Kotlin, by the way, this is more like Java. If I said something like string foo equals null. In Java, this would crash the program with something called a null pointer exception, because we're attempting to invoke a method on nothing. We're storing null, which essentially means nothing. Nothing's in there. And we're trying to call a method which is invoking behavior on nothing. That's what we call a null pointer exception. If that's a bit confusing, don't worry, because Kotlin handles it a bit better. In Kotlin, what we can do is we can use something called the question mark operator. So I can say var foo :string equals null. Now what's going on here? I'm making a variable named foo. I'm specifying that I'm going to hold string data in it, and I am setting that equal to null, which means I'm essentially holding nothing in that variable. Okay? Notice I get a compile error here. because it says I can't assign null to the type foo. That's a non-nullable type. So what I need to do is I need to add a question mark after string, and that question mark says I'm allowed to store a null in this variable. Next, I can say foo.length, okay, and we will store this in a variable called length. So normally if you call length on a string, you will get the number of characters in that string. But here remember, I haven't put anything into that string yet. I've assigned it as a null reference, which means it's pointing to nothing at all. Not even empty string. Empty string is a different concept. This is a null reference. Now, because I've declared this as a nullable type, anytime I refer to this foo variable, I have to add a question mark to say, hey, this might be null. Now, here's something interesting. Let me go ahead and have a previous breakpoint there. Let me go ahead and let that run. What is actually stored in that variable called length, if the variable on the left called length, what's actually stored in that variable? If I call a property or a method named length on the variable foo, which is holding nothing, which is holding null, what happens over here? In Java, we know that would crash the program with a null pointer exception. So how does Kotlin handle it? Let's find out. I'm going to move my changes up to our emulator. Just one moment. And with the changes propagated, I click on the button. Let's watch the debugger and see what happens. Just a moment, I need to set a breakpoint here. Let's try that one more time. And we'll click the button. Okay. And we see that, okay, I can go to run and step over. And we see that the variable foo has null. And again, null is not a string. It means nothing. It means it's not pointing anywhere in memory. Now, what happens when I call the property length on nothing? Let me do run and step over one more time, and we see the variable length is now set to null. So the way that Kotlin handles this is it simply cascades that null value up if we call a property or a method or a function, whatever you wish to call it, on a null reference. It simply passes null back, where Java would throw the null pointer exception. Okay, let's consider one more scenario. Let me go ahead and tell this to continue. What if we say, okay, I realize by the question mark here that this might be a null reference. If it is not a null reference, I want to use that value. But if it is a null reference, I want to give it a default value. Okay, in that case, we use something special. We use what's called the Elvis operator. The Elvis operator is the question mark and colon. So question mark colon, and let's say 10. So let's say if foo is null, instead of cascading back that null value, just use the default value 10. Let's watch what happens now when I go ahead and I push these changes up. And just a moment as the changes propagate up. I click on the last button. Okay, I choose run and I choose step over. Okay, and you see that foo is still null. Okay, now here's the important part. We call length on a null. What's going to be stored in our variable on the left? So run, and we'll do one more step over. And if you take a look here on the right, you see it takes the value 10 and uses that if it notices that we're calling length on a null reference. Okay? Now let's try this one more time. Let's try it one final time, and I'll go to resume program. Let's try it one final time. But this time I'm actually going to store something in the variable foo. We'll store bar. Okay? We're no longer storing a null reference, we're storing bar. If we're storing a string, then length should return the number of characters in that string. Let's take a look. I propagate the changes, and we'll give it, of course, just a moment. Okay, I click the button. And now let's watch carefully as I choose run and I choose step over. And you see that foo now contains the string bar. And I step over one more time. And we see length now contains the value 3. Because it's giving us the count of characters in bar, it no longer needs to pay attention to what follows the Elvis operator on line 55. So that answers the question then. What happens when you call a method on a null reference? You either get a null in return, or you can use the Elvis operator to default it. Before we close, I want to consider one more thing that we can store in a variable. Let me go ahead and resume this. So far, we've used a variable. Well, we've used one as a constant. We've used one to hold an integer. We've used one to hold a string. These are all essentially data types that come with our project, come with Kotlin. But let's look at one that we made by ourselves a while ago. If I go to our app and I go to source and then main in Java, under DTO you see I've made a special type called plant. And this plant is what we call a value object or a plain old Java object if it were Java, or a DTO, a data transfer object. Essentially what we would traditionally call a Java bean. It's a noun that represents a plant, and it's made up of attributes which we can consider adjectives. If you consider what an adjective is, an adjective describes a noun. So this starts with a global unique identifier, which is an integer, then a genus, a species, a cultivar, a common, each of those are strings, and then a height. But we don't necessarily have to define height because you see I have given it a default value here. And with a default value, if we don't pass in a parameter for height, it just runs with that default value. So let's take a look again at our activity. And let's consider how we could use var to say redbud. And then we can say redbud equals plant. And we simply pass in these parameters. A unique identifier, a genus, which is Cercis, a species, which is Canadensis. And then what else do we have on plant? Let's take a look, just refresh my memory. Did we have cultivar? I believe so. So sure enough, cultivar and common. Cultivar we can just leave empty. Honestly, I could make that null, or I could make it double quote, which is empty string. In this particular case, that doesn't matter too much. Just a moment, let me zoom up so we can see this in high definition. Okay. Then we have common name. This is Eastern Redbud, which is a common tree and a very outstanding tree, by the way, in the Midwest United States landscape. That's it. So at this point, we have stored a constant, an integer, a string, and even a more complex object, which is made of more simple types aggregated together. And if I want, I can give the redbud a height of maybe 15 feet, or let's be more international friendly and call it 5 meters. So either way, I'm taking a complex object, storing it in a variable, a string in a variable, a number in a variable. Each time the variable type is simply var if it's something we're going to change later, or val if it's going to be a constant. So this has been a look at variables,